So I'm going to be showing you how you can run multiple PLP in Patient Prediction version 6 to develop multiple prediction models. And also I'm going to show you how to do external validation as well. So for this demo, I'm going to be using the Eunomia package. This is a Hades package that has simulated data. And if you use the function Eunomia get Eunomia connection details, it will give you a connection details to an SQLite database. So I'm going to run that now. This has created an SQLite database. And then if you use the function Eunomia create cohorts, what this is going to do is going to create 4 cohorts that can be used for playing around with the code if you don't have data. If you have data in your CDM, you can actually use the database connector function to create a connection details, and then you can actually create your own cohorts, and then you can actually use those in this example. But for now, I'm just going to be using this Eunomia that has the simulated data. So you can see in Eunomia, we've got 4 cohorts created into the cohort table. We've got 3 drugs and 1 outcome. So for this demo, I'm going to be focusing on NSAIDs to start with, for model development to predict GI bleed. But I'm also going to then show you how you could externally validate that model on a target population that's a different drug. So the first thing when you're doing prediction, whether you do a single model or multiple models, is you need to create a database details settings. And what this is you're going to be using the create database detail function in PLP, and then you're going to be specifying your connection details. So in Eunomia, we got this created, so you have this here. But if you were doing your own database, your own CDM, then you'd need to have your own database connection details here. Now with Eunomia, the CDM database and all the cohorts schemas, they're all in the main. So we're going to see for every schema, it's main. The database name and the ID I've called Eunomia because we're using the Eunomia data. And then the cohort table and the outcome table is cohorts. This is where Eunomia has created these 4 cohorts into the main schema, into the cohort table. I've specified my target ID as 4, NSAIDs, and my outcome ID as 3, which is GI bleed. So if I enter that, that's my database details set up. Now, when you're doing multiple PLPs, it's become model-centric. So in version 6, we've actually made it so you create a model design, and you can create multiple model designs, and then you can run prediction for each of these model designs. So a model design consists of a target ID, which is actually, this is worth mentioning, you don't actually have to specify if you're doing multiple PLP, you don't need to specify these 2 in the create database details. This is actually more for run single PLP because these are actually specified here for the create model design, but it will just ignore these IDs in this object when you're doing the multiple PLP. So a model design consists of a target ID, an outcome ID, what it is you want to predict, who you want to do the prediction for, restriction settings. So this is just if you want to sample, so you can, or if you want to pick certain dates to filter in, basically filter and only use index dates if they're between these start and end dates you specify. You can say whether you want to restrict to first exposure. So if someone's have multiple NSAIDs, if you set this to true, you just look at the first time they had the NSAID. And then you can specify washout periods. So you can specify that people have to have been observed in the database for a certain number of days prior to their index, prior to their first or any occurrence of their NSAID, depending on what you've selected here. And then sample size means that you can specify whether you want to take a sample of your target population. This is really used if you just want to do a quick feasibility. So if you have a cohort, NSAIDs, pretty popular drug, there may be millions of people in the database who have that. Maybe you don't want to develop a model initially with millions of patients. You just want to see if it's feasible. Then you could sample a number like 100,000. And then you can do the development a lot quicker to see if it seems like something that could be predicted. If you don't have time constraints and you probably just want to use all the data you have, in that case, you wouldn't use the sample size. And then population settings. This is where you're going to specify additional inclusion criteria that gets applied after you've downloaded the data, and you're going to specify your time at risk when you want to try and predict the outcome occurring relative to the target population index. So population settings, the main inclusion criteria is first exposure. We saw this in the restrict here. We also have this here, so there's some redundancy, but the difference between first exposure in this setting, and the first exposure in this setting is done at data download. So this means if you specify it in the create restrict PLP data settings, your downloaded data is going to basically have to match this inclusion criteria. So if you say first exposure here, you're downloading, you're only going to get the first exposures once you downloaded the data. However, if you didn't specify any restriction here and you said here first exposure, this is going to be doing it when you're running the model. So if you wanted to see what was the impact of first exposure, you could create two model designs. You don't specify it in the restriction. You specify true for the first exposure in one design, and you keep the same settings in the next model design, but you just set first exposure to false. And then at the time you're fitting the model, it's going to then do the filtering to first exposure for the first design, and it's not going to filter on the second design. And you can see what impact that had in the internal validation. You can look at external validations as well. So the study population settings are what gets applied once you downloaded the data. The restrict PLP data is basically the restrictions that get applied before you download the data. So if you're doing a sensitivity and you want to investigate sensitivity, I recommend putting it here and not here. Then you've got washout period, and again, the same applies. It's in this setting here for the restriction, and it's in the setting for the population. Depends whether you want to be able to look at sensitivity, but this is basically saying I want at least 180 days prior observation for my patients in the target population, and I need that to create the features. Then whether you want to remove people who have the outcome prior. So this will look at whether someone had the outcome before their target population index, and if they did, if it occurred within 180 days of index. So if they had it 30 days prior to index, they get excluded. If they had it 179 days prior to index, they get excluded. If they have 180 days prior to index, they get excluded. But if they had their outcome 181 days before index, they would still be included in this case. If we want to remove people who have the outcome anytime prior, we can just put this as a really big number, and then we're going to remove anyone who had it prior. Required time at risk. This is looking at whether someone's observed for the whole time at risk period. So if you're doing the prediction for 30 days, are they observed in the database for 30 days after their index? If they dropped out after 7 days, then if you set required time at risk to true, you would actually get rid of those people. So this is just what you do to people who have lost the follow-up. We recommend, based on research, to set this to false. It could cause a bit of a calibration issue, but you can recalibrate. So it's better than having a bias, which can happen if you put it to true. Then these settings here are used to define your time at risk period when you're trying to predict the outcome occurring. So here, what this is saying is I'm looking at 1 day from my cohort start date, the NSAID start date, to 30 days after my NSAID start date is when I'm trying to look for the GI bleed occurring. You can set this if you wanted to do 1 year. You can set it to 365 here. You can pick whatever time at risk you want. And again, the good thing is with this run multiple PLP, you can actually investigate all of these very easily because you can just copy the design, paste it, and then just modify whatever things you want to adjust. Covariate settings. This is what features you want to include. So we've got gender, age group, and condition group error long term. These are the features we'll be including in our model. I want to highlight, similar to the single PLP and the multiple PLP, both of them, the thing they have in common is that pretty much all of this is customizable. You can add custom code for feature extraction. You can add custom code for feature engineering, for sampling, for pre-processing. Actually, I don't think we have custom code. That's actually you just need to specify what you want of the options. But you can have custom on the model settings, custom on the split settings. So there's customization for pretty much the whole part, all of the different aspects of the model development. Feature engineering. I set this to null. I'm not going to do any feature engineering in this design, but there is the possibility now that you can create functions to manipulate your features and however you want, and you can do some feature engineering. There's examples of that on the website. Split sample settings. So this would be if you want to over or undersample your outcome population, or people with the outcome versus people without the outcome. Preliminary research has shown this isn't good to do because it causes calibration issues, but if you want to do that, you can. I'm not doing it in this example, so I've set that to null. Pre-process is whether you want to do any normalization. or remove redundancy. So if there's covariates, two covariates that are completely correlated, whether you want to remove one of them. Min fraction is if there is extremely rare covariates, do you want to remove them? So you can specify a min fraction of 0 means you'd include all the covariates that's created by feature extraction. 0.01 means that you would only keep covariates if at least 10% of the target population have the covariate. 0.01 means you'd only keep it if at least 1% has it. And here you've got like basically 1 in 1,000 have to have it. So you can specify how common a covariate has to be for it to be included as a candidate predictor. I'm just actually going to set this as default, which I believe is like a 0.001, so it's like a 1 in 1,000 for this. Then you can specify model settings. So I've picked a lasso logistic regression. Basically, we have a library of classifiers, and if you put the set here and you press tab, you'll see most of these, other than this set Python environment, all of these are classifiers or survivor models that you can pick. And within each of these, there's going to be settings for hyperparameters that you can either use the default, or you can specify how you want the hyperparameter grid search to be done. The lasso regression is the one I'm going to show in this example, but as I said, you can pick any of these. And then split set also, before I actually move on, you can also write whatever classifier you want. This is completely customizable, and there's instructions on how to do that. So you're not restricted to the ones we have in the library. And we always recommend if people add it to the package so other people can use it as well. Then split settings, we're going to use the default split settings. This is how you split the data into test, train, and cross-validation. So here you've got a fraction you can do for the test, which by default was 25%. Fraction you can do for the train, which by default was 75%. Split seed, so if you want to reproduce things, you can get 100% reproducibility. N folds, so for cross-validation, how many folds you want to do. By default, this is 3, but you can set it as 10 or 20 if you've got smaller data. And then the type, by default, this is stratified, which means that the outcome proportion is going to be the same in the test and the train and all the folds. This option here, run covariate summary, is just if you have really big data, this covariate summary can be quite slow because we're using SQLite to do the aggregation of the features, and it doesn't scale well. We are potentially moving to a different backend, which may make this quicker, but in the meantime, I've added this as an option. So if you don't really care about the covariate summary, the descriptive statistics about the features, and you just want a model and you just want it quick, you can actually set this to false to make things a little bit quicker. But if you're not worried about time, then I recommend putting covariate summary equals to true, so you actually get information about how common the features were in the test, the train, the people with the outcome and the people without the outcome, and so. So this is our model design 1. And then for model design 2, I basically cut and paste. But what I did is I've changed the risk window end to 365 days. So this should be exactly the same unless I made changes. So making changes, nope, this looks like it's exactly the same other than this time at rest. So I've got exactly the same model. I've got a lasso logistic regression. And both of those I'm mostly using the default settings for everything, using the same covariates, but I've changed the time at risk. If you wanted to, you could do additional models to see what's the impact of adding different covariates, what's the impact of using a different model. And you just do as many model designs as you want. Just give them a different name. And then let me just actually create these. So this is just going to create a list of the designs. Then now we've got our model designs, we've got our database details. That is pretty much all we need to run multiple PLP. So the function run multiple PLP is going to take your database details that tells you where your OMOP CDM data are, where your cohorts are, and the connection details. You put in a list of all your models. You could put as many models as you want. And then you want to put a save directory. Where do you want the output? So where do you want to get the models that are going to be fit? You're going to have the final model, you're going to have the predictions, you're going to have the evaluation metrics, and where do you want those saved? So you can just specify here that folder. Now I've commented this input here this is optional. The cohort definitions is one input to run PLP. Because I'm using Eunomia, we don't have those cohort definitions. However, if I was using Atlas to create the cohorts, I could use our Odyssey Web API export cohort definition set function specify the IDs. And what this would do is this is going to create a data frame or table, I think, with the JSON and the SQL of the cohorts, so the NZ and the GI bleed, if we would use Atlas. And then if you input this into the run PLP, this is actually going to be saved so that when you view the results of the Shiny, you're actually able to also view the JSON and the cohort definition in a friendly way. So this is actually, I recommend using. We can't use it because Eunomia, it doesn't have an RO, it's not a web API, so we don't have the cohorts. But if you had an Atlas and you had your cohorts designed in Atlas, you could run this simple script to get the cohort definitions. But like I said, this cohort definitions are optional. I recommend it because it does make the Shiny nicer. You can actually look at the cohorts, but it's not needed. So if I run this now, it will actually start to run the two models. So first, what it's going to do is extract the data for these two, the data that's needed for these two models. Then it's going to do the diagnostics. So it's going to look at whether your model designs seem valid for your data that you've got specified in the database details. And then it's going to develop those models. And then when you view it in using view multiple PLP, which you just have to specify the location you specified here, you'll be able to look at the diagnostics and see whether the data was valid, and you'll also be able to see how well the model did and explore it. So this view multiple PLP is really handy, and I'm going to have another video where you can actually see how to use the latest view multiple PLP. Now it's worth highlighting that if you wanted to then develop these models in a different database, all you'd have to change now is this database details. So you just have to have the database details specifying the new OMOP CDM, and you keep the same model designs. And if you run that with the new database, you're going to get exactly the same design models developed, but on a different database. And you could save this design list, give it to someone else. They could then create their database design, load in your design list, and then they could run the equivalent model development on their data. The model design plus a database clearly just basically specify a unique model. So if you were to do view multiple PLP, you could now view this results. I'm not going to show this because I'm going to have a video dedicated to that. One thing I wanted to show before I finished was how simple it was to do validation. So if you want to now validate the model, and you can change you could either change the database. So if you had another OMOP CDM database, you could create a new connection details to that database. You could change your database names and the schema settings, and then you could apply your model. But what I've done, because I don't have another database, I'm just going to show you it by showing how the model does if there's a different target population. So for the validation code, the target and the outcome IDs are used in the database details, and they will actually enable you to do validation on different IDs. So if we go to, so if I create this is basically a new database details object. I can simply use this validate multiple PLP, specify the location where I output. So this is the same location here and here where I actually save my models to. And then I put in the new validation details. So the database is the same, but the target population ID has changed. And then I specify that I want recalibration done. I just want weak recalibration. I can now press enter here. And what this is going to do is for every model saved, so there's two models that we developed, both of those models are now going to get validated by using the second target ID. So this is like the second drug we had that Eunomia simulated in the Eunomia dataset. So we're also looking now how the model did when we looked at a slightly different drug population. And like I said, you can change the database, you can change the target ID, you can change the outcome, and you can do validation very easily just with these 5 lines of code. So this is how simple it is to do validation of multiple PLPs.